I'm not able to see list of all the participants.
सर अभी एडमिट नहीं किया सर, कर रहे हैं अभी।
कर दो।
और वैसे भी सर साथ में ना YouTube लाइव भी जाएंगे।
तो ठीक है, पर उनको पता तो चले मेरे को कि
जी सर,
एडमिट करवा दो, because then it becomes
और मैडम कैसे हैं आप?
ठीक हो सर, आप दुआ।
ग्रेट। अभी कॉलेज में हो या रिटायर हो गए?
Retired a year and a half back.
Oh,
Almost 2 years now, because September 21 I retired.
okay, okay.
Saloni,
Saloni, ma'am,
both
please check
forwarded,
on.
both
जी,
links
ma'am.
forwarded,
हाँ जी मैम,
and I'm admitting all.
ठीक है मैम।
सर अब पार्टिसिपेंट्स विजिबल होने शुरू हो गए होंगे सर।
हाँ, शुरू हो गए।
हाँ, बाद में अब सर बाकी जो होंगे YouTube लाइव से भी ज्वाइन कर लेंगे।
Okay,
सलोनी के पास सर रहेगा एक्सेस
right.
फॉर क्वेश्चंस फ्रॉम देयर।
You can start.
So ma'am, shall I start?
Yes,
Yes.
please.
A very good evening to our esteemed resource person, faculty members, and participants. I, Saloni Arora, on behalf of Ramanujan College and Indian Accounting Association NCR chapter, welcome you all to today's session.
मीनू मैम को क्या 2 मिनट में आ रही हूँ।
Welcome you all to today's session of the 2-week interdisciplinary refresher course on research methodology and data analysis. I would like to take the honor to introduce our resource person for the day. Professor C.P. Gupta sir is a PhD Finance from Department of Commerce, Delhi School of Economics, University of Delhi. He has teaching and research experience of more than 30 years. His areas of research, teaching, and consultancy include investment decisions, risk analysis, project appraisal, security analysis, fuzzy decision making, and financial modeling. Sir is a life member of the Operational Research Society of India, Society for Capital Market Research and Development, and the Indian Financial Management Association. He has contributed a number of articles in various Indian and international journals and has research-based books to his credit. Sir has also guided a number of research students. Sir, I don't think I've done justice to your introduction, yet we are absolutely honored to have you
Saloni, that's
in
more
this
than
learning
enough.
journey, sir. Without much delay, over to you, sir.
Sir, before may I request Rekha ma'am to just say a few words, like definitely उनका भी addition यहाँ बहुत जरूरी है sir before you
बहुत
start with the
जरूरी है।
session.
Thank
Please
you,
sir.
sir.
Ma'am.
I would definitely like to welcome. It's my proud privilege and honor to be here with a teacher, a scholar, an erudite scholar, someone who has not only teaching experience, but also an administrative experience of more than. And besides that, as a senior professor in the faculty, he has taken up many initiatives to make sure in Delhi University we introduce a lot of interesting opportunities for researchers as well as for young teachers. And I'm sure we have Anjali Gupta here as one of our Professor Anjali Gupta as our example, who has benefited by being Professor C.P. Gupta's PhD student. So we all are really very fortunate to have you with us. And I'm sure the students are going to learn a lot. And I also thank you. We are indebted to you.
Thank you, Rekha ji. Thank you for all the nice words. And really grateful to you. You're always motivating us with your nice words. Okay. So, Anjali, should we start?
Yes, sir. We can start now, sir. Thank you, sir.
Okay. So, friends, This is the session in which we are going to talk about univariate analysis. So in univariate analysis, we have only one series, and we are trying to capture different characteristics of that particular series by using different parameters, different statistics related to that particular series. So one series, and how much information that series is giving to us, that is something which we have to appreciate in this particular session. So friends, every session has a motive behind it. So this session is also having a motivation.
Requesting all participants to please be on mute throughout the session. Thank you.
Thank you, Saloni. So the motivation for this session is we have to understand research and then analyze data to answer the research questions which we have in our research. Because every research is having certain research questions which we have to address by making use of data. So friend, let's start our session with two thoughts. And normally I share these thoughts with all of you whenever I begin my presentation. If you cannot explain it simply, you don't understand it well enough. That's important for us because when we take viva of the students and we ask, what is this you have done? And if they are not able to explain that, that means they have not understood what they have done. What is expected is whatever you are doing, you must understand it. And if you understand it, you can easily explain it. If you don't understand, you cannot explain. You will be caught here and there. And there are many teachers in the participant list, and I hope they must have experienced it. Whenever they have a topic in which they understand, in which they have a confidence, they can explain to the student in a very simple way, and the students understand that. And that gives a lot of confidence to the teacher. So as a researcher, as a teacher, please understand. If you understand, you can explain. If you don't understand, you cannot explain. So friends, throughout this session, my focus will be make you understand. And in that process, if you have any question, you can put your question in the chat box. I will love to answer those questions. But make sure that whatever we are discussing, you understand it. Okay? Second, if you know nothing about the statistics, you are missing, excitement of life. We cannot, we cannot imagine today's life without statistics. Wherever you go, you see statistics. Whatever you do, you have statistics, you confront with the statistics. And if you don't like it, if you hate it, you will be really missing some excitement in the life. So friends, start loving statistics. Don't hate statistics. If you start understanding it, I tell you, you will really love it. It gives you a lot of potential for getting inferences from the data. The statistics is a journey from data to wisdom. So you have data, and from that data, you're trying to get inferences, and those inferences are nothing but the wisdom which we are getting out of. So we have to learn statistics to build our own capabilities to deriving meaningful results from our data, and also help our students to understand and derive meaningful conclusions from their data. So we have to build our own capability, and we have to build our capability of our friends, our students, and others. To do research, we have to design it and decide how to do it. That's the problem of research designing. Every research requires a proper design of the research. These are the different components of a research design. Define the information you require to answer your research questions. Design kind of the research to be undertaken, whether it's qualitative research, quantitative research, experimental research, causation research, or descriptive research. You have to define what kind of research you're going to take. Specify the measurement and the scaling procedures. If you're using a questionnaire, construct and pre-test a questionnaire or an appropriate form for data collection. It may be primary data, it may be secondary data. You must know what exactly you want. And you take only that data and nothing else. Because if your data is suffering from measurement error, then your conclusions will not be correct conclusions. You will get wrong inferences. So make sure that there is no measurement error in the definition or in the measurement of your variance. Specify the sampling process and sample size, developing a plan for data analysis. All those things you will find, these are the basic steps of a particular research design. Now, before I proceed further, I ask you a question. And I want your response. How do we define return on assets? Anyone? You can put your response in the chat box, no problem. How do we define return on assets? I hope many of you are familiar with accounting and finance. Salonia, do you think participants are able to put their queries in the chat box?
Yes, sir. So they're writing. If any participant wants to answer, please unmute and answer or write your query in the chat box. Yes, sir. They are writing. They've been given the access.
Participants, okay, my question is, how do we define return on asset? Yes, Dr. Naseem, how do we define now return on assets?
So one has replied, net income divided by total assets.
Right. And friend, how do we define return on equity? Yes, Dr. Priyanka, how do we define return on equity? Yes, Priyanka. If return on asset is defined as net income divided by total assets, then how do we define return on equity? Priyanka, please come on. Priyanka. Anybody else? Anybody else? I mean, I'm not asking a very difficult question. It's any net income divided by shareholder and net income divided by shareholders. Okay. Shareholders fund, also known as net worth of a company. Now I have an issue here. Do you think return on asset and the return on equity can have same numerator? I'm getting total return on the total assets by using net income. Shareholders return also using net income. Is that correct? Is that correct? Yes, T. Karunakar. My question is it right to measure return on asset, net income divided by total assets, and return on equity, net income upon shareholders fund? Is it possible to use the same numerator for two different ratios representing total different perspective about the profitability of a company? Return on asset gives an idea about the total profitability. That is how much return a company is earning of the total assets. And return on equity represent how much income company is earning of the shareholders fund. Now I've taken this example because I've seen a lot of people are doing mistake. This is not the right way. And if you take this as net income upon total assets, return on equity as net income upon shareholders fund, you are having what is called measurement error. And you might be questioning that return on asset in literature is defined as net income divided by total assets. So my reaction is that's not the right way. Total return on the total asset is what we get of the total assets of a company, and that's equal to your EBIT upon total assets. Then out of EBIT, how much we are distributing among the debt holders and the government, if we exclude that, only the difference net income we give to the shareholders. So please be careful in defining your data. If you use your data wrongly, if your data is having measurement error, I can show you and prove your results will be biased, inefficient, inconsistent, and nobody will accept those results. Priyanka, is that clear? I don't know whether you have understood or not. Yes, for ROE, we use the owner's part of the assets. So that is the net income. So please be careful about the measurement error, and that normally happens and we get wrong results. Think what is the most important input for the research? So you have a research, you need output. What is the most important input for the research? You will find it's nothing but data. So you input data, process, and get the desired results, output. So in that sense, we say data is very, very important for the research. What do we do with the data processing for answering the research questions? So you have research questions, and for answering those research questions, you have to process your data. Say, for example, I want to know in UP, what is average wage of migrating labor. That's a research question I want to answer. Of course, you will say you have to take data and using that data, you have to come out with appropriate measure so that you can answer this particular question. By using necessary statistical tools and software, because these days nothing is manual. So if you want to really, access your process data. So what you need understanding about statistics, which are you going to use, plus, because these days nothing is manually. So we have to make use of some software. So we should have knowledge of that particular software. That may be Excel, that may be SPSS, that may be R, that may be Stata. But you need some software to process the data. So please note that we shall use Excel and SPSS for data processing in this particular session. What is the first thing we should do with our data? If you get data in your hand, what is the first thing we should do in that? Quick. And mostly I've seen people don't do that. What is the first thing you should do when you get data in your hand? Always make it
Ms.
clear.
Divya says identification. Anushruti says summarize, feed data in software.
Saloni, that's a different thing. But very first thing which you have to do with the data is you have to make graph. Okay. Kiran Dubey says cleaning. Of course, cleaning is to be done and data should be properly designed. Assuming everything is done, after that, the very first thing is you have to make graph. Why do we need graph? I mean, you might question me, why do I need a graph? What is that I am going to get out of the graph? Behavior of data.
So Ms. Divya says check normality.
Check normality. That is the behavior of the data which you have. Okay. Of course, you can see normality. You can also identify outliers. And also gives you an idea what kind of a modeling you should do. If you have a data, something like this, maybe you need a linear relationship. But if you have a data like this, then you need a quadratic relation. So graph will tell you whether you need linear relation, quadratic relation, cubic relation, whether your data is having outliers or not, whether your data is normally distributed or not. All those things you can get from graphs. So graphs are very, very important. Okay. So there are a lot of graphs, but in research, we make two important graphs. One, histogram, and another is box plot. These are two important graphs we should always have. Yes, Vimlesh, when you put your data on a graph, you can also get an idea about the trend in the data. Yes, Vimlesh, you're right. And trend is useful when you are working with time series. But if you are working with the cross-sectional data, then there will be no question of any kind of a trend. The purpose of histogram is to check normality and identify outliers. Box plot is very powerful and tells about median and skewness. Yes, Divya, what else? Box plot is very powerful. Not only it gives you the idea about the center tendency in terms of the median, in terms of the skewness, it also gives you something else. So we use a histogram in the normal curve, and you can have a histogram with a normal curve like this. It shows up your distribution is very close to normal distribution. It's only visual, nothing else. And we cannot make a histogram for nominal data and ordinal data. We can make histogram only for scale data. Quite close up to normal distribution. It only gives you the visual effect, whether it is actually following normal distribution or not. We have to check and test statistically. So different tests for checking and testing normality. But that's how you can see the graph. Then we have box plot. This is a horizontal way. But you can also make vertical box plot. Yes, Anu Shruti says range and variability. That's good. Yes. This is Q1 minus 1.5 interquartile range. An interquartile range is defined as Q3 minus Q1. This is Q1. This is Q3. This is median. This is lowest. This is highest. And any number beyond that will be your outlier. Like here. It's an outlier. So anything which goes beyond this, you will see it's an outlier. Now I have a question here. I have a graph like this. I have a graph like this. What does it mean? This is median. 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 I make one more. What is it?
So Ms. Divya Sharma has replied variance.
Divya, I will not say it's a variance, it's a variability. So this is having low variability in the data. This is having comparatively higher variability. So we get an idea about the central tendency. We get an idea about the range or the distribution, the variation. What about these lines? What they represent? This represents the skewness. This is median is in the center. So that shows my data might be following normal distribution. This is skewed. This is also skewed. Now, what is it? Positive skewness or negative skewness? Is it positive or negative? Yes, this is graph A, B, C. C represents normality because it's in the mid. 50% this side, 50% that side. So that's normal. What about this? Which one is positively skewed, A or B? Which one is positively skewed, A or B? Quick, quick, quick. See here. So B is positively skewed. A is negatively skewed because A is having tail on the lower side, B is having tail on the higher side. So box plot is powerful in the sense it gives you an idea about the central tendency. It gives an idea about dispersion. It gives an idea about the skewness. It also gives an idea about the outliers. So if you have something here, that's an outlier. So in that sense, I say Dheeraj is saying B is, Dheeraj, B is not negative, B is positive because you have a long tail on the positive side. And in case of A, you have a long tail on the lower side. It also helps in comparison. You can compare their means and find out whether there are differences in their central tendencies or not. Do you appreciate the importance of the box plot in terms of information conveyed? The answer is yes. And I will show you a little later how can we make box plot in SPSS. Let's see what next we are going to discuss. We are going to discuss basic characteristics of the data in terms of descriptive statistics. So descriptive statistics is measured in terms of four major characteristics: measure of central tendency, dispersion, symmetry, and okay, so we all know what is mean, what is median, what is mode. I'm not going to discuss here, but my issue is What is the probability that X is less than equal to median? Anyone? Any number less than equal to median, what is its probability? Anyone? Saloni, I'm seeing a lot of names left join in the messages. So can we delete this? I want to just
Yes,
see.
sir.
I just
I'll
want
just
to
delete from the chat. Yes, sir.
Anu Shastri says 0.5, 50%. What is the probability that X is less than equal to me? Yes, Anu, can you try? Since median is the middle value, therefore its probability is 0.5. Therefore, it's wrong to say that probability of any value less than equal to mean is 1. That means it is certain all values are less than equal to mean. Probability of X less than equal to maximum value. That I can say 1. But what is the probability that X is less than equal to mean? No idea. But if it follows normal distribution, then it will be 50%. Otherwise, I cannot say. I cannot say whether it will be 50%, more than 50%, less than 50%. I cannot say. But in case of the normal distribution, yes, Anu, you're absolutely right. In case of normal distribution, it will be 0.5. You might be wondering why I'm talking like this. Because when you derive meanings out of it, maybe you want to derive meaning in terms of probability. So you must know what is the probability of X less than equal to median, greater than equal to median, less than equal to mean, greater than equal to mean, that you have to find. And what is the probability of X less than equal to mode? That will be maximum. What will be that maximum? I don't know, but it will be maximum because mode represents that value which is having maximum frequency. So it will give you maximum probability. But how much? Again, no answer for this. Okay. Now let's look at some of the properties of these measures mean. The algebraic sum of the deviations of the given set of observations from arithmetic mean is 0. That means summation of X minus X bar is 0. Property number 2. If you change the origin of a series by P, your mean will be changed by P. So if I want to calculate expectation of X plus C, that will be equal to expectation of X plus So that will increase or decrease with the shift in the origin. And please remember, when I say expectation, I'm talking about the mean. So when you multiply any x with p and you calculate the mean of it, expectation of it, this will be equal to p into expectation of x. So if you multiply all observations by p, the mean will be multiplied by p. Sum of square deviations from mean is minimum. And this property is so important that my OLS estimates in the regression are based on this property. Divya, I don't understand what you mean by use mic at the end of every sentence. What does it mean? Saloni, what does it mean? Use mic at the after every sentence.
Divya ma'am, I think you can check your network. It's absolutely clear at our end. So your voice is clear.
Okay.
Thanks.
So this property, that square of deviations from and its sum will always be minimum. And for that we use a OLS. Okay. Median, the sum of absolute deviations of the given set of observation is minimum when taken from the median. That is, if I take absolute deviations from median, summation of it, that will be I know what do you mean by efficient? I know what do you mean by efficient? The spread is minimum. Okay. You know, mean is having very important property. There's a, and we say, mean is unbiased estimator. Mean is consistent estimator. Mean is efficient estimator. Mean is sufficient estimator. And that's why whenever we have to estimate central tendency of any data, we love to have mean because of these properties. And when I say efficient, I know what does it mean? The variance from mean is that's why we say it is efficient. Consistent means as you go on increasing sample size, the sample mean will tend towards population. The expected value of the mean is always equal to population mean. Sufficient because it makes use of all information. Median. Median is not unbiased. Median is not consistent. Median is not efficient. Median is not sufficient. So as a researcher, you must understand what is that I have to use for my research. The only problem with the mean is it is influenced by extreme values, that is the outliers. So if you have a lot of outliers in your data, maybe you don't use mean, you may go for the median. But otherwise, always use mean because of its nice properties. Any question before we go ahead? All of you know how to calculate mean, so I'm not going to do that. All of you know how to calculate median, all of you know that. But what we are supposed to know, their properties. And that's what I am focusing more. Any question about properties? If each observation is increased or decreased by P, the median, the new series will also be increased or decreased by P. And if each observation is multiplied or divided by a non-zero number P, the median will also be multiplied by the same number. There are some of the properties of the median. And the relationship between mean, median, mode helps you in getting an idea about skewness. If all three are equal, then we have normal distribution, no skewness. If mode is more than median and mean, we have negative skewness. If mode is less than median and mean, then we have positively skewed distribution. So graph tell you a lot of things about, nature of the distribution, nature of your data, and all. Any question about central tendency? Any doubt, any query? Variance. And these are some of the important things which you have to remember. Variance of a constant is always zero. Variance of x plus c is, so adding is constant, subtracting a constant doesn't change variance. What is the variance of ax plus c? That's equal to a square variance of x. If we have two variables, x and y, both are independent, then variance of x plus variance of y. If they are dependent, then variance of x plus y will be equal to variance of x plus variance of y plus 2 times covariance between x and y. Please remember these properties because these properties we use heavily, especially in portfolio theory of the finance and in econometrics. Any questions here? Please don't hesitate. It's your program and you have to understand what we're talking about. Okay, so if you have addition, then standard deviation will be same. If you multiply, okay, let's apply. These are my outliers. And this looks to be normal. But this does not look to be normal. Variation by and large is same. It's not different. So by looking at a box plot, you can get a lot of things out of it. Look at this graph. This graph looks to be more normal. And this graph looks to be more skewed. And may have an outlier somewhere here. And this is the mean. This is the standard deviation. This is variance, skewness, kurtosis. So if I compare these two data, which one is more pickedness? Which one is having more pickedness? Price or total revenue?
So there's a question. Please explain why the lower green box plot doesn't look normal.
This one.
So previous to that, the 3 box plots. Yes, sir, the
Because,
green one.
This is not in between. It's not in the middle. Not in the middle. Had it been the middle, I could say the distribution is purely normal distribution, symmetrical distribution. But since it's not in the mid, it's lower than the mid, then it shows it maybe have skewness. And this is actually not total revenue. This is price. The price is more skewed, having more peak as compared to total revenue. And that's what is reflected here. Higher kurtosis, lower kurtosis. More skewed, less skewed. More variance, less variance. And many times I've seen now, many of you report descriptive statistics in your paper without discussing them. So reviewer says that why you are writing descriptive statistics in your paper if you don't explain it, if you don't interpret it. So when you write descriptive statistics in your article, don't forget to interpret them. Don't put the table as it is and leaving it to the readers to interpret it. No. You as a researcher has a responsibility to explain what this descriptive statistics tells. Okay? Any questions here? Yes, Divya. Median is not in the middle, therefore it's not. Yes, Anu, thank you. So any question before we go ahead? Any doubt, any query? No? Okay, let's move to our next item of the agenda, that is hypothesis testing. For every hypothesis testing problem, we require a test, and that test may be parametric and non-parametric. So let's understand what is the difference between a parametric and non-parametric. But before that, what is parameter? What is parameter? Anu, Divya, anyone? What is parameter? Yeah. What is the meaning of parameter in the statistics? Any measurable quantity? No. Noun is not a parameter. Characteristic of the population. Yes, Anu. Parameter is related with population. And statistic is related with the sample. So if you calculate mean from the population, we show it by mu. And if we calculate mean by using the sample, we denote it by. So when I say parametric test, that means it is a test which makes assumption about the population. Pooja, it's not necessary that population should be normally distributed. No. Yes, Dr. Gayatri, something in population that's called a parameter. And something related to sample is called statistics. Okay. Pooja, why do you believe that every population will be normally distributed? This is not correct. Divya, what do you mean by large number? So please don't keep this conception in your mind that we always assume that population is normally distributed. No. Divya, what do you mean by large number? Please. Population is large number. Population is broad and sample is part of it. Yes, Pooja Tiwari, that's true. Okay, in this context, I would like to share with you what is called a central limit. Or CLT. What does it say? Dheeraj, greater number for large sample, Manjari Vartak. Vibha KMC. Simple sample is part of population, right? Yes, Divya. Saloni Divya want to speak. Can you allow her?
Sure, sir. I'll just do that.
Sir, according to me, when there is a central number, as we have just learned in the central tendency that the mean is represent the whole population, so central limit theorem means that the population is always around that central limit. That's why it is considered as a normal distributed.
No, it's not that. Central limit theorem says distribution of means will tend to follow normal distribution if sample size is tending to infinity. Central limit theorem does not assume anything about population. Population is normally distributed or not normally distributed, doesn't matter. It says that sampling distribution of mean will always be a normal distribution if your sample size is large. That's what it says. And mean of it will represent the population mean, because the expected value of sample mean is always equal to the population. Yes, Vibha. If you increase the sample size, distribution will be increased. Distribution will be increased. What does it mean? Normal. Divya, are you able to understand what I'm saying? Please understand this. I'm not saying what is happening to my population distribution. I don't care. What I say that the sampling distribution of mean will tend to follow normal distribution if sample size increases to infinity. Divya, I don't know what you're trying to say. Under CLT. And what does it mean under CLT?
The central limit theorem.
What you're trying to say? As sample size increases, the mean calculated shall tend to be a normal distribution. No. What is normal distribution? Not the mean, but the sampling distribution of mean is normally distributed. Please understand my words. Central limit theorem says sampling distribution of mean will follow normal probability distribution if you increase your samples. That's what it says. Divya, is that clear? So please understand, I'm not assuming that the population is normally distributed. What I'm assuming that the underlying distribution of the mean, which I'm calculating, that is following normal probability distribution. So if I make assumptions about population parameters, then I'm using what is called a parametric test. Such tests make certain assumptions about the nature of the population, like normal probability distribution of the population, or we know standard deviation of population and all. So if you make any assumption about population, then it is called parametric test. These tests are very rich and developed, and they are very powerful. Okay. What is alpha? Type 1 error. What is it? Beta. Type 2 error. What is alpha? What is type 1 error? Probability of rejecting a true null hypothesis is my alpha. And beta is probability of accepting a wrong null hypothesis is beta. And 1 minus beta is called power of the and parametric tests have a larger power of the test as compared to non-parametric. So therefore, given a choice, always use parametric rather than non-parametric. These are also called a distribution-free method. They don't make any assumption about population, and we call them as they lack parameters. And we use them widely in case of nominal data and ordinal data, where no parametric test is available. These tests are not very powerful and strong in assertions. Non-parametric statistical tests are typically much easier to learn and apply in the parametric test. These tests usually convert data into ranks, hence lose information. Okay. If your data is nominal, and ordinal, always use non-parametric. Always non-parametric. But if your data is scale level, and assumptions of parametric is not true, use non-parametric. If it is a scale variable and assumptions are true, then use parametric test. I hope this is clear to all of you. Never use parametric on nominal and the ordinal data. Always use non-parametric tests for this kind of a data. Scale data, if the assumptions are true of the parametric test, use parametric test, otherwise go for non-parametric. Is it clear? Okay. Suppose my sample size is 200. Should I use T statistics or Z statistics? You will give me the answer. It's not a small sample, it's a large sample. Should I use T statistic? Should I use Z statistic? Divya says T, but why T? Why not Z? If you have a large sample, why you are not using Z? Why T? Dheeraj saying T statistics, but my question is, why not Z? Your sample size is 500. Why not Z? Why T? Dheeraj, sample is finite. No, Dheeraj, that's not the answer. I increase the sample 1,000, 5,000, 10,000. I can go and increase in the sample size. Divya says just the size of the sample make the difference. So Divya, what you suggest, Seneca Shala is saying depends upon the type of the data. Type of the data is say scale data. Marks of the students. Yes, Divya. If standard deviation is not known, standard deviation of population is not known, then we use T statistics. Another reason, why should we go for T statistic and not Z? As T increases, Swanlata, that is very arbitrary number, but what I'm saying is if N is increasing and going up to infinity, the T value converges to Z. For large sample, there is no difference in the T value and the Z value. If you see the table, T table, after that, after some point, it start giving you Z value. So for a large sample, it doesn't make a difference you use T or Z because you are going to get the same statistics. T statistic we prefer to use because it is based on the assumption that population standard deviation is not known to us. Because many times I find students have a question. They say that if my sample size is more than 30, so why I'm not using Z, why I'm using T? They still have a valid reason to use T. First, the standard deviation of the population is not there, which is the assumption for the Z statistics. And second, for large sample, T value and Z value, they are same. So all software you will find gives you T values rather than Z values. No, I know it's not because of the central limit sample. No, it's not because. So let's see where we should apply what test. And first we are talking about parametric. When data is measured at a scale level and assumptions about the specific test are non-parametric when it is measured at nominal scale or ordinal scale, and when assumptions of the parametric are not satisfied, then we go for non-parametric. What is the difference between independent t-test and paired t-test? Okay, Divya, paired is used for post and previous. That means you have a pair. I take a difference. Null hypothesis is mean of 1 minus mean of 2 is equal to 0. That's my null hypothesis. And I calculate pairwise difference. In case of independent t-test, we say null hypothesis is say mean of 1 is equal to mean of 2, but we take mean of it, we take mean of second, and we check. Here we do not consider pair. So that means this is we use when samples are independent. And this we use when samples are related. So if you have related samples, your test will be different. If your samples are independent, your test will be different. Yes, compare the samples of the same entity. That means the samples are related. Say worker 1, productivity before training, productivity after training. So these are two related because they are coming from the same person. This is called related sample test or the pair t-test. So please understand independent sample test and related sample test. It may be for 2 samples, it may be for n samples. Parametric test can be used only for the scale data. One sample test, mean test. Which test we use here? Central tendency test, the T or Z. Normally we use T statistics, but if it is for the variation, we use chi-square. So if you want to check whether the assumption null is variance of NSC is equal to 0.02, then you have to use chi-square. If you say mean return on NSC is 15%, you're using this. And if you are having 2 samples, related samples, pair t-test. And if they are independent, we use independent t-test. Variances of both the samples are equal and variances not equal that you have to consider while testing for the difference of. When the variances are equal, you will use some test. If they are not equal, you will use. Okay. In two samples, interval scale variation test, we use a F test. F test is a test of equality of variance. And if you have more than two samples, then we use equality of means or analysis of variance or ANOVA. And equality of variance, we use Levin's test. So this is the brief outline about different tests which we can use for different kind of samples, one sample, two sample, more than two samples, related, unrelated, all those things you can. So let's take some sample and see how we can apply them. So there is a folder with the name of test for data set for parametric tests. So I take out
So there's a query on YouTube. The example you gave for paired t-test regarding change in productivity by training, can it be used to also compare the different levels of productivity by different trainings but to the same worker? Please clarify.
by different.
By different trainings but to the same worker.
By different.
Sir, I'll repeat. The example you gave for paired t-test regarding change in productivity by training, can it be used to also compare the different levels of productivity by different trainings but to the same worker?
Okay. So in that case, what will happen? We will have different samples for the same person. Same person will be trained for different training modules. Isn't it?
Yes, sir.
Say person X, right? Trained for training 1, trained for training 2, trained for training 3, right? This is what you want to say?
Yes, sir.
So how do we check whether the mean of the training 1 is equal to the mean of the training 2 is equal to mean of the training 3? Right? Here we use what is called repeated measure of because I'm doing this experiment, different experiment of the same person. So I'm repeating. It's a repeated measure of anomaly. In that case, we use this. Because all the samples are related. More than 2. So we use repeated measure of anomaly. Is that okay, Saloni?
Yes, sir. Thank you so much, sir.
Okay, so we have size of the company and we have P. So do you think which set of the companies are having higher P ratios? Small companies or the big companies? So I go to analyze. Descriptive, compare means univariate. Analyze, compare means independent sample t-test, because the big companies and the small companies, they are different. So my test variable is P ratio. Grouping variable is code. So 1 and 2. And that's the result we get. So small size companies have a mean of 110. Big size companies having a small. And F-test says the variances are not equal. Saloni, where is the annotator in Zoom?
Sir, your network went a little haywire. I think the participants are also saying, please show again. We couldn't hear you for
Where
30
is the
seconds.
annotator in the
Sorry, sir.
annotator in Zoom?
Sir, I still can't get you.
Annotator in Zoom. Normally I used to see that, but today I'm not able to see it.
I just checked, sir.
We don't have that option. Normally we have an option of annotator, but here we don't have that option.
Even I can't. No, sir.
Anyway, if you see here, F is not. F, null hypothesis, variances of both are equal. And this is not accepted, rejected. So we should use the second one, variances not equal, assumed. So T statistics is this, degrees of freedom is this, significant value is 0.056. So at 5% level, we can say that there is no difference, but at 10% level, the small companies are having more P ratio as compared to the big companies. Okay, so Saloni, I'll stop it here. I take a break, and after the break, we will come back again and discuss.
Yes, sir. So for the next session, we have a separate link.
Yes.
Yes, sir.
So after how much time?
Sir, as you say, it's 6:43 right now.
So 6:45.
Sir, in 2 minutes.
53.
Okay, sir.
10 minutes.
6:50.
Text me
Sure,
10
sir.
minutes.
Sure, sir.
So we will
All
meet
the
after 10 minutes.
the link will be shared on the Telegram group itself. Thank you. Thank you so much, sir.
Okay.